Hi everyone. If you follow me on social media, you've probably seen that I post a lot about industrial control panels, industrial controls, and industrial IoT. Probably the number one question I get asked when I do post about things like that is, what is it? And it's easy to forget there's a lot of you that probably have never seen this stuff and don't know what it is. So in this video, I'm just going to do a quick introduction to industrial controls, just to explain what some of the things are, so you've got a better understanding of what it is I'm posting about. Okay, while I explain this, I'm going to use a fictional theme park and a fictional roller coaster, just to add some context to what these devices do. Okay, so the first thing I want to introduce are PLCs. So that's these two devices here. PLC stands for Programmable Logic Controller, and basically they're industrial computers that are built to process inputs from sensors and to output to a signal to things like actuators, drive controllers, and things like that. Typically run on 24 volts, and they come in a variety of flavours. This is a Siemens logo, which is like a little baby PLC. Get these for under £100. This is a Simatic Siemens S7 1200. These are a couple of £100. And then you can get additional modules that add on to them to add extra inputs and outputs to them. They're great in harsh environments, so perfect for factories where it might be hot or cold. And you'll also see these in lots of other places. So just thinking back to our theme park and where we might see these, the chances are on a roller coaster you might see a PLC controlling the roller coaster. So it will have inputs from sensors to say where the car is in the station, and then the ride operator would have a control panel within his control box with a bunch of lights, for example, that should all be green before the ride can be launched again. And then when the ride's ready to be launched, he can press a button. This tells the PLC that it's ready to go. The PLC then starts the ride launch sequence, and probably starts some sort of motor drive to winch the car up to the top of the ride and start the ride. Okay, so let's move on to talking about inputs and outputs. So inputs and outputs typically come in two flavours. You have analog and you have digital. Digital inputs are where a signal is either on or off, and analog outputs are typically where a signal is between a range. So for example, 0 to 10 volts, you could have a signal that's 5 volts and we can measure that. Or you can have a current signal, for example, where it might be 4 to 20 milliamps, and we're measuring the current between those two known points. If you had a sensor that's a positional sensor, you might know that the 20 milliamps means that something's in one position, and the 4 milliamps means it's in the lower end of the position. So by measuring that signal, we can then scale that signal to the known output of that sensor, the known positional values of that sensor. So let's say it was a rotary sensor and you had 0 degrees would be 4 milliamps, for example, and 360 degrees might be 20 milliamps. So if we had a signal of 12 milliamps, then we could know that that sensor is at the 180 degrees point. If it was at 90 degrees, then the sensor would be at the sensor would output 8 milliamps, and if it was at 270 degrees, then the sensor would be outputting 16 milliamps. So just thinking about how this relates to our roller coaster. So we talked about how the ride operator can launch the roller coaster by pressing a button. When he presses that button, that's a digital signal that's coming, could come into one of these modules, or it could go straight into the PLC. Let's just make the assumption that it's coming into this module. It comes into this module, the module detects that the signal's changed and then has a different status. So it now has this on status. This PLC could be reading from these input modules, and it's reading them, waiting for the signal to change, detects the signal change, and then the launch sequence starts. When it comes to our analog I/O, perhaps the launch sequence that's been initiated by this PLC actually tells one of our analog output modules to send a analog signal to a drive controller, and that drive controller will determine how fast the motor spins, and so how fast the winch operation happens. So perhaps we're using it to say, right, let's pretend on this fictional roller coaster we've got 3 modes of operation. We've got slow, medium and fast. So by sending different analog signals from the I/O device, we can tell the controller, the drive controller, whether it should be in fast mode, slow mode, or in a middle mode. Okay, so we've talked really briefly about analog and digital I/O. What we haven't talked about is how these I/O modules can talk to PLCs. So you'll notice on these I/O modules they have Ethernet ports. These PLCs also have Ethernet ports. We can create a network, and then using industrial protocols, these devices can talk to each other. Okay, so then we can then create the network using things such as this, which is just an industrial switch. So it's the same as you kind of find in your office, but industrial version. We've got a modem here, cellular modem, 4G, and then we have this device here. So this is a protocol gateway. So where a device doesn't support a particular protocol that you need it to support, we can use these gateways to basically convert from one protocol to another. Okay, so let's just move on to this row of devices here. So here we've got a Schneider PowerLogic PM5110 power meter. This we can use for monitoring the power consumption of various things. So maybe you want to see how much power the ride's consuming. This is a protocol converter. I'll come back to that in a second. This is for detecting water, and this is a temperature sensor. Now these two sensors here and this one here rather than using Ethernet, they use what's called RS485 for communication. So it's an old Modbus technology that's been around for decades, and we can plug them into here and then convert from the Modbus RS485 to Modbus TCP. This enables then the newer devices that maybe don't support RS485 to talk to it. Okay, and then something that's not on this board is this. So this is a HMI, so these come in different sizes and configurations. This is a little one with 4 function buttons on it, and essentially this is a display. So it can display graphics and information, and we can have it connected to our PLCs so that when we're running a program on our PLCs, we can have this display various information about our sensors and the process that's running. Okay, and then finally down here, right at the bottom, we've got these modules here. Now, these are Phoenix Contact PT Fix distribution blocks, so we can feed in, say, 24 volts into one of these, and then use this to distribute the 24 volts to the rest of our devices. These are marshalling panels, so when we're building a control panel with all these devices in, rather than the engineers that are attaching the control panel up to everything having to connect into all of these, we can pre-wire this into these marshalling panels, so it's very easy for them to connect all the sensors, etc. up. Now finally on our board we've got 2 more things. So we've got our edge compute here and we've got our BMS here. So let's just start with the BMS quickly. So BMS stands for Building Management System, and in our theme park we've got this within the station building, and this device here is running the HVAC, so that's the heating, ventilation and cooling, and you'll find these in commercial buildings pretty much everywhere, running the heating, the cooling and the boilers, etc. Then moving on to our edge compute, we've got 2 examples of edge compute here. We've got edge compute by OnLogic, and we've got one by Brainboxes. These are Linux-based computers, low-powered, so these can run off of 24 volts. I think these are both 5 to 30 volts that they run off of. and we can use this to run kind of more traditional programs. So, for example, we use these when we're doing IoT deployments. We run a piece of software called Azure IoT Edge on them, and then that software allows us to write custom modules to talk to the different sensors and PLCs, etc. And then we send that data up into the cloud. Okay, so I think that concludes our brief introduction into industrial controls and industrial IoT. Obviously, there's a lot more to the subject, and maybe we'll do some breakout videos in the future, kind of looking at specifics. There's a number of things we didn't talk about, so maybe we'll cover some of those as well. I hope you've enjoyed watching, and if you've got any questions, please put them in the comments.